So these are the notes for Sanger's algebra class, section 13.4. So these notes basically are talking about recognizing patterns with tables. And so if we think about the patterns we've already seen in algebra, if we look at an XY plane, and if we think about a line has a starting point or an intercept, and then we go up and over the same amount, up and over the same amount. So it's a repeating pattern. And so the up here is the same no matter where you go. So notice that up is the same, and then the over is also the same value as every other over. That's how we make a line, as we just keep repeating that pattern. So when we look in the table, we'll see the numbers on the y column jump up by the same amount, and we'll see the numbers in the x column jump up by the same amount. So if that's not happening, it's not a line. So we're going to look at ways where we can distinguish that in a table. Looking at the x values and the y values, that's what we're looking at. The x values, those are the horizontal ones, we call them independent. The y values, those are the vertical ones. So these are horizontal, these are vertical. We call these dependent because usually there's an equation like a y equals that where we put in an x to get the y. So if we look at this pattern here, here's the first picture, okay? And so in this first picture, we see one rectangle. The perimeter means count how far down, over, up, and back to the beginning it is. So the perimeter is measuring that outside. So if we look at this picture, we have a 1 by 6 rectangle, which means we have 1 down here and 6 over here. So 6 plus 1 is 7. And notice we have 7 again coming back on the other side of the rectangle. So the perimeter is 7 plus 7, or 14. So we get that 14 by doing 6 plus 1 plus 6 plus 1. Okay? And so the ordered pair then is this. For one rectangle, we have a perimeter of 14. So notice this is the x, and this is the y. And so we could graph that on a plane. Okay, now we take a look at two rectangles next to each other. So in the picture, we see two rectangles. And the perimeter here would be counting 1 plus 1 plus 6 plus 1 plus 1 plus 6. So 1 plus 1 is 2, plus 6 is 8, plus 1 is 9, plus another 1 is 10, plus 6 is 16. So the perimeter of that triangle is 16. So in other words, we're ignoring this in the middle because it's kind of like you could try to erase that because that's not the perimeter, that's not around the outside. So this ordered pair then looks like two rectangles. That's the independent variable that's drawing the picture, has a perimeter, an outside distance of 16. So now we look at this next picture. So three rectangles next to each other has the perimeter here. If you notice, we have 1 plus 1 plus 1 plus 6, and then plus 1 plus 1 plus 1 plus 6. So if you notice, when I add this up, 1 plus 1 plus 1 across the top, that's 3, plus 6, that's down the left side, that's 9, plus 1 plus 1 plus 1, that's the bottom. So that is, now we're up to 12. Remember, 3 plus 6 is 9, plus another 3 is 12. And then up the right side, plus 6. Okay, and so that whole total is, I lost count now, 3, 9, 10, 11, 12, 18. There we go. So this ordered pair is for a picture of 3 rectangles. We have a perimeter of 18. And remember that perimeter is counting just the outside, so it's ignoring this stuff in the middle. And so if we take a look at what we're writing down here, I'll put a little star above it. Notice we're adding 1 and 1 each time, right? We had 1 plus 6, 1 plus 6, and then we had 1 plus 1 plus 6, 1 plus 1 plus 6. Then we had 1 plus 1 plus 1 plus 6, 1 plus 1 plus 1 plus 6. So if we look at the last pattern, for 4 rectangles, we're going to have 1 plus 1 plus 1 plus 1, 1 plus 1 plus 1 plus 1 plus 6, and then around the bottom, the same thing. So each time we're adding 1 for the top and 1 for the bottom. And again, we're ignoring all this stuff on the inside because that's not the perimeter. Okay, so this perimeter is 20. So if we notice the pattern here, the x's go up by 1 and the y's go up by 2's every time. So if we would graph this, this would be a linear relationship because we have the same thing happening up for every x, the same change, and we have this for every y we have the same change happening. So that would graph a line. So if we draw our ordered pairs, we have 1, 14, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. There's our first point. 2, 16. So I'm going to go over to 2 and up. And remember, I'm at 14 here. I'm not gonna put too much on my axes. I just know that for the second point, I'm going to go over to 2 and I'm going to go up to 16. So this is 14, then I go 15, 16. So there's my next point. And then 3 is going to be moving this way. And then up 18. So remember, I'm at 16 right here. So I'm going to go 17, 18. And then I'm going to go over to 4. And I have to go to 20. So remember, I'm at 18 here, 19, 20. So when we graph those points, you can see that that makes a line. So let's take a look at this pattern. We're still talking about perimeter. So we're talking about adding up the lengths along the outside. Okay, and we're talking about a triangle it's got three sides. 2 of the sides are 3's and 1 of the sides are 4. So they're not all the same. So looking at the picture, number of triangles, when we have one triangle, it's this picture. We have a perimeter of 3 plus 3, that's 6. Plus 4 gets us all the way back around to the beginning, that's 10. So I know we don't have the table here, but that first point then would be for one triangle, we have a perimeter of 10. Okay, now let's look at picture number 2, and remember perimeters along the outside, so we're going to ignore this. So we have 3 plus 4, so we have 3 plus 4 plus 3 plus 4 plus 3 plus 4. So that equals 3 plus 4 is 7, plus 3 is 10, plus 4 is 14. So that point for the picture for 2 triangles is a perimeter of 14. The next picture for 3 triangles, so again, I'm going to remind you, we're talking about perimeter, so we're not paying attention to the stuff on the inside. When we count the perimeter, it's going to be 3 plus 4. So 3 plus 4, 3 plus 4, plus 4, another 4. So we have 2 4s across the bottom, so we have 2 4s there. And then we come around to the right side, plus 3, and then to the top, plus 4. So adding that up gets us 3 plus 4 is 7, plus 4 is 11, plus 3 is 11, 12, 13, 14, plus another 4 is 18. Okay, so this ordered pair for a picture of 3 triangles as drawn above, we have a perimeter of 18. And then for the last picture, 4 triangles as drawn above, we've got 3 plus 4 plus 4. So 3 plus 4 plus 4. It's kind of starting out a lot like the other one. And then plus another 3. So that's bringing us over to the right side. And then across the top, we have plus 4 and plus another 4. So if we add all those together, 3 plus 4 is 7, plus 4 is 11, another 3 is 14, another 4, excuse me, is 18. That's got us to that one. And then that last 4 gets us to 22. So this ordered pair for a picture of 4 triangles as shown, we have a perimeter of 22. So if we look at, again, if we look at the pattern, we see that our x pattern is up 1, and that happens with every x value. And our y pattern is that we're going up 4. And that happens for every y value. So again, this is going to be, if we would graph this, we would end up graphing a line. Because we have, the x's have a consistent pattern and the y's have a consistent pattern. Okay, so this is kind of summarizing what we've been investigating up here, and that is a function. Okay, a function is a relationship that pairs the x's and the y's. Okay, so that input value is that x. And the output value is the y. So it pairs an x and a y. And the two, like we mentioned, the two above are linear functions. They would make a line if we graph them. So we have a table below, and we want to, it says the relationship between the number of photos you take and the amount of memory left on your camera. And it's asking, is this a linear function? So we don't know if it is. We have to look for the pattern. Okay, so we look at each column separately, and we see if we can find that repeatable pattern. So from here to here, looks like we add 1. And from here to here, looks like we added 1 again. And from here to here, looks like we added 1 again. So we're halfway home. We see a repeated pattern here. Now let's look at the y's. From here to here, as you take more picture, you use more memory. So if we're describing how much memory is left, right, remains on that memory card, then the memory that remains is going to go down. So we had 512 and we took a picture, and now we're left with 509. So that means we went down, which is a negative value, 3. Okay, and if we take another picture, looks like we went down 3 again. And if we take another picture, it looks like we went down 3 again. So notice that we have a consistent pattern for my x's. They were always going up 1. Okay, we have a consistent pattern for my y's. We're going down 3. So this, since we have a consistent pattern for both the x and the y's, this would graph to a line. Okay, so the description of the relationship is that it's linear. And if we look at how the y changes, the y is going down 3, and the x is going up 1. So now that we've got three good examples of a linear function, we want to take a look at a nonlinear function. So nonlinear functions are functions that aren't going to make lines. Okay. So for instance, these three functions in this top row are all linear. Okay, so these three are all linear. They make lines. They repeat a pattern. And we can see this repeating pattern is going up 1 over 1, up 1 over 1, up 1 over 1. And this repeating pattern is going over and down. And this repeating pattern is just going over. And the up or down is 0. So those are all repeating patterns. Nonlinear functions. I like to use this descriptive term. Nonlinear functions either bend, in other words, make a curve, or they turn. They change direction. So in other words, we have a bend here. So this one turns from going down to going up. We have a turn here, that kind of a twist, if you will. And this one definitely turns around here. So if you see anything bending, turning, or twisting, it's not linear. Okay? So, and we should be able to see that in our tables as well. Okay? So if we look at these tables, and this is, since I see decimals here, so I'm going to grab my calculator on the decimals here. And I'm not going to worry too much about graphing it right now, but let's just look at the patterns. On the x's, and a lot of times the x pattern will be the same. So let's take a look at this. It's the y pattern that will start to be different. So this looks like a +2, and then here to here is another +2, and from here to here is another +2. And from here to here is another +2. Okay, so we're halfway home. We see the same pattern on the x's. That's up 2. Now let's take a look at the y's. I was using purple for y. Okay, so for the y's, from here to here, in order to figure that out on our calculator, we have to go 50.27. Let me move that actually. To figure this out, I'm going to do that up here. I need a little more space. We have to go 50.27 minus 12.57. And you can do that by hand if you want to. I'm going to, just to make this video shorter, I'm going to do it on my calculator. So 50.27 minus 12.57. That gets me 37.70. And it's going up. Notice the numbers are getting bigger. So this is plus 37.70. Okay? And that's just the first one. So this next one, we're going to have to subtract again. It's going to be 113.10. Notice I'm taking my more recent one, and I'm subtracting the older one, 50.27. So when I do that, 113.10 minus 50.27, I get 62.83. It's going up, but it's going up by a different amount. So this is plus, because it is going up, it's getting bigger, 62.83. So notice we can already say that this, if we graphed it, would be non-linear. It's not going to make a line because the y changes are different already. I'm going to take a look at this one, and I'm not going to write it because it's hard for me to write on the computer. So I'm going to take 201.06 minus 113.10, and this is getting bigger by 87.96. So again, it's changing. So that reinforces that this is not going to draw a line. It's going to draw some sort of curve. So we're going to have a curve here. Okay, it's going to bend or it's going to twist or something. And this last one, just for kicks and giggles here, this last one is 314.16 minus 201.06, and that is 113.1. Okay, so since those are changing, and we only have to have one change, the x's didn't change, and that was okay. But since the y's changed, we know we're going to graph a curve. Let's take a look at the sauce cost. Okay, so I didn't pick up on this, but I'll mention it now. This was calculating the area of a pizza. Okay, so pizzas are, circular. So these were the area of the pizzas. So that was not linear. That's going to be a curve. But let's take a look at how much it costs to provide sauce for those pizzas. So if we look at 2 pizzas to 4 pizzas, that's a plus 2 again. So if we notice this column is the same as the column before, so we know we're going to have plus 2's all the way down. Just a quick visual inspection. So we know we have a constant rule of up to here. So let's take a look at this side now. So again, this is money, so we're going to have to subtract. We're going to have to go $1.60 minus 80. And when I do that, I get 0.80. I get 80 cents. That's a decimal point. 80. Okay. So so let's take a look at the next one. So now we have 240 minus 160, $1.60. And if you do that, you can do that in your head here, right? We get a 0. We carry the 1. 14 take away 6 is 8. Bring down our decimal point. 1 take away 1 is 0. So we have 0.8 again. Okay, well, that's encouraging. It changed the same on the first 2 tries. Let's try the next try. So when we take $3.20 and subtract $2.40, so $3.20 minus $2.40, we again get 80 cents. So it changed the same again. And the last time, we got to check every one just to make sure one doesn't change differently. If we take $4, so we have a lot of scratch work on the side of our paper here, but that's okay. And we subtract $3.20. Okay, then 0. Make that a 3. Carry 10 over here. I get it, and again another 80 cents. So we see that the y values are changing the same amount. Our rule here is up 0.8 or 80 cents. So since our rules for the y's are all the same and our rules for our x's are all the same, this is going to be a linear relationship, where when we graph this, we're going to be graphing a line. And I think that's the end of the notes. So again, really, I think this is a good summary page here. On the left side, we see the changes are different for each step down the table. So that's going to give us our curve. And here the changes are the same for every step in the table, and that's going to give us a line.